My name is Carlos, and I'm going to be explaining the process for calculating queuing delay for the nth packet. So I'm going to be walking you through this example problem, and I'll just read it out real quick. Suppose you are an indie game developer and you are currently tasked with testing network performance for a server. While testing, your server receives 30 packets all at once, and each packet contains 6 megabytes of critical game state data. The network link transmits data consistently at 1 gigabit per second. How do you calculate the queuing delay for the 25th packet? So the first step is to gather the important information from the problem. When we calculate queuing delay, we care about the length of the data, the transmission rate, and the packet number we're calculating our queuing delay for. For the size of the data, we know that each packet contains 6 megabytes. We also know that the server transmits data at 2 gigabits per second. And we're calculating the queuing delay for the 25th packet. So the next step that I would take is to convert each of the values into the appropriate units. To convert the size from megabytes to bits, we multiply 6 megabytes by 1024 kilobytes, and we make sure to cancel out the megabytes unit through our division. And then we multiply the answer by 1024 bytes and divide again to cancel out the kilobyte unit. And finally, we multiply our answer by 8 bits and divide to cancel out the bytes unit. So this will give us our total in bits. And then for the rate calculation, I'm just going to ignore the time units until the end. So to convert the rate from gigabits per second to bits per millisecond, we start with our 2 gigabit per second transmission rate. So first we'll multiply the 2 gigabits by 1000 to convert to megabits. Next, we multiply 2000 megabits by 1000 to convert to kilobits. And then we multiply our kilobits by 1000 bits to get bits. So finally, we divide our answer by 1000 to convert our bits per second to bits per millisecond. So this will give us our final answer for our rate in bits per millisecond. To calculate our delay for the 25th packet, we use the formula n minus 1 times L over R. So to start, I calculated the L over R, which comes out to approximately 25.166 milliseconds. And then I calculate n minus 1. And the reason we subtract 1 from our packets is because we assume that the queue is empty. So the first packet shouldn't have any queuing delay for the purpose of our calculations. Our n minus 1 is equal to 24. So to get our answer, we multiply our two answers together to get 604 milliseconds after rounding. So these are the problems I came up with, and I'll read them out. Suppose you work in IT at a small startup. Your company needs to back up a small amount of data. They transfer 50 packets containing 10 megabytes of data each. These packets enter the server queue at the same time. You know the network link transmits data at 9 gigabits per second, and you want to know the queuing delay for the 14th packet. Work this problem out. For problem 2, suppose you work at a fintech startup. You want to ensure system integrity, so you test the network by sending 60 packets to a server. Each packet contains 8 MIB bytes of mock transaction data, and they enter the queue at the same time. The server link transmits data at 5 gigabits per second. How do you calculate the queuing delay of the 19th packet?